So after getting the DEM, and now we are entering into the most important step. From this point, we are actually telling the ISE to do the processing. So in this, we have to understand what is stack sentinel dot py right now. So I just run some commands because um, I wanted to show what kind of errors do you face. So this is the command which I have entered, and this is the error I got. So I'll just explain you what I did and how I did. So from that you can understand, and you can also follow the script. And if you have any other errors, you can just let me know in the comments. I will explain you. So here, stack sentinel.py. This is the main workflow preparation of which lets the ISCE to work like a processing chain. It will not generate interferogram. It will not calculate the displacement. It will prepare the entire workflow progress. So what it will do is it will read all the Sentinel SLC products, the 15 products which we have kept it in the folders, and it will read the precise orbit files which we have downloaded, and it will read the DEM and also the bounding box which we have mentioned the area of interest, and from that it will take the master image as a reference. So someone of you asked me like, are we going to select the master image or ISC is going to do? So with this tag sentinel.py, it will select the reference master image. And after that, it will calculate the temporal and also the perpendicular baselines. And after that, it determines which image pairs should form the interferogram. And it will create the complete processing workflow. And the most important thing it produces is the running scripts. That means those scripts are created by this stack sentinel.py, and those scripts when you run one after the other, the steps will automatically do the processing. Now, uh, sentinel stackpy, when I run, it is asking for an error saying that traceback, and the file is like this, and module not found, no module name top stack. That is because what I'm usually doing is I'm trying to explain every step in detail and what kind of errors do you have. Okay, so what I did is, now what I did is I tried to run the stack sentinel.py, and I got this error saying that module not found, error. No module name top stack. That means when we uh, check the path here on the top, we had one error like this, and then about the fetch orbit. Then we tried to see the export path, and from there we created the path for the fetch orbit, and then we created the path for stack sentinel py. Now what is happening? Python module is searching for Python path. Okay, there are two complete different things. Python is different, sorry, path is different, and Python path is different. So path variable. So here this is Python path. Okay, and here where we are here on the top is path. So path means finding the executable programs. Python path means finding the Python packages. So here what I did, stack sentinel py, and I got this error. Now I'm asking the Python path. That means find the Python package. Now we need to fix this path. This is because it should like I think when people say I found sentinel stack.py, everything should work. But Python also needs to know where these ISE2 libraries are located. Till now, we said only Ubuntu is asking for the locations, that is path. But now we are running the Python scripts which are created by the ISCE2 and the Stack Sentinel. So we need to mention the Python program also to uh, know where the ISCE2 libraries are located. Now what I did, I typed the echo Python path and then I found this location and find the exact stack location. I've typed find Miniconda 3 Mintpy share ISCE2 and the name as stack. Then I got strip map stack, allo stack, and top stack here. So my top stack is located at this place. Now what I did is I have found the stack sentinels actual path here, and from there I went to the Python path. From there I have selected the location. So what I did is instead of going from the first again, I wanted to activate these paths because many Conda packages automatically install the activation scripts. So that's why I told you if you wanted to process the data in one particular environment, you have to create that environment. That is why we have used Conda activate Mintpy. That means whatever the data you are processing, it will be only in the Mintpy environment. So it doesn't create any kind of clash. So when you are using this kind of environments like Mintpy, base, ISE2, then the particular or the related files will be created only in those places. Okay. So here what we did, we have carefully added everything and the activation scripts are shown here. So I have asked the conda activate.d. That means I asked for the what files do you have in this folder? Then it shows 1, 2, 3, 4, 5, 6 like that. In this, I have this ISCE2 active. So this is more important because we are working on the ISCE2. See, this concept may be little new to you people, or it can be little confusing also. But if you keep on practicing with some data sets, then you'll understand clearly. And the most important thing is once you cross these hurdles, then for the next time, you don't have to think about this again and again because that will automatically happen. And you don't have to even think or worry about any kind of other errors that are coming. Because once you have cleared, then this whole um, script will understand. Okay, these are the things. All you have to do is just place the data in the required folder and then you start the processing and it will continuously take the data and it will do the processing itself. So this is only a one-time hurdle. Now what I did, I have checked for this locations. This script is automatically executing when we are running the Mintpy only. So I have this in Mintpy all the way from here, 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 everywhere you see. I'm doing it in the Mintpy. Now there is a packaging issue. That is why I got these errors here. I'll just show you the errors also. Okay, so now what I did is I wanted to clear that error before I go for the next stage of processing. So what we did is we wanted to determine whether the stack sentinel pipe is intended to run directly or whether it must be launched as a Python module. Okay, so for that I have gone through this command had -30 Miniconda environments made by share ISE2 top stack sentinel pi because that is located in one of these packages. So I've done that one and I got the location user bin environment and then this is the whole details of that stack Sentinel Pi. And after that, I wanted to check the remaining files also. So again, I have opened ls, Miniconda 3, environment, Mintpy, share ISE to top stacks. This is because we wanted to inspect any kind of important statements, the folder structure, how it is, and whether top stack is a Python program or something else. If it is, then we'll have to fix the environment properly. And what I did, again, I took this path and then export this IICA2 path, and then I have added this eco path again. Then I got my central path type ph, and the error is resolved here. So this is just the configuration of what you have. When I type the same stack sentinel pi.h here in the beginning, I got one error, right? File no module found. Okay, no, or no module name top stacks. But after clearing all these errors, I was able to get the proper details of this thing. That means now we are ready for the next step. In the next step, we'll discuss more about. So in the next step, we wanted to create one more folder which contains the auxiliary data. So in this step, we are preparing the auxiliary directory required for the top stack workflow. So here, why do we need an auxiliary directory? That means besides the Sentinel products, the precise orbits, DEM, area of interest, we also need one auxiliary calibration data that is important during the processing, because these auxiliary files contain information that will help ISCE to correctly interpret the Sentinel-1 measurements, even though we are using a smaller area, and also they are much smaller than the SLC products, but they are very important for the process chain. So, and when we are creating, like I told you how to create that. So just create uh, and make here like this P, and I want X. So if you see ls, along with that I got ops also here. See, now I got this ops folder also. Okay, at this point the aux folder will be empty, but this is normal because for Sentinel-1 processing, auxiliary calibration files are typically downloaded automatically by the ISCE2 wherever it is required. And beginners usually forget about creating this aux directory, and using the orbit directory as the aux directory. These are two complete different data sets. Orbits contain precise orbits like .eof files, and aux contains Sentinel-1 auxiliary calibration files. See, there is no confusion in that. When you are going for normal processing in ESA Snap, if you go to the installation folder, you can see this orbits, aux, and all other files. Same way we are doing it here, but only thing is we are keeping everything ready first, and then we are running the script so that everything will be automated. Just because this video is long or just because the steps are long, you don't think this is the hardest part. Once you are mastered this technique, then you can run any kind of data. I mean, like any data in the world, all you need is the Sentinel data, the DEM, and the orbit files. After that, all the processing will be done by the ISE2 and Mintpy, and you'll get the data automatically. So, please have some patience because we are learning, and we'll go for the next step. Now, we are trying to build the Sentinel stack sentinel.py. So, what I'm doing is I'm telling the ISCE2 about the locations and the files and everything. So what are we doing? We have created this Sentinel-1 precise orbits, carbon depth, and then area of interest and the auction directory. Now, you just have to understand what I'm typing here. Here in the central stack pipe, I've typed minus S showing SNC. Minus S means it specifies the directory where the SNC files are located. And after that, I have typed minus O, which means it represents where the orbit files. Minus A, it's not minus, actually it's hyphen ops. And then D, showing the location where the dem files are. And B is the bounding box. And then M here, you have the date. I mean, like, date in the sense the master image. If you really don't want to have the master image, this one, then you can edit. But let this image be the same, because this most important thing will decide the whole processing. So the reference image becomes a geometric reference for the entire stack. And W is the interferogram. Okay. So what I can do is I'll just um, go for the enter option, and then I'll show you the thing. See, run files folder exists. And then it said, please remove or rename the files and folder exists. Okay. So that means in this, if you go back, you can see run files. It says it wanted to create a run files folder, but it is already existing. So it is asked to delete that folder because it wants to create its own folder. So I can just delete that one. And then again, I go for the same. See, this is the error what I got. The reason why I got this error is what I'm going to explain to you again. So these are the most important things what you should understand to when you are learning something. You should understand why this is happening and what kind of errors do you get. So coming to this error, okay. So we have cleared the error, and now we'll go for the extract and by again. This one for the entrepreneur. And now we have created the 15 files, and then we got this latitude, longitude, and all dates covering this box, and essences are correlated, and then correlation method is using the NASD, and the interferograms are formed here. Now we'll go for the next step. There are few things which I am not explaining you clearly because uh, This need to be explained once you have a proper understanding of the environment and the dependencies. What I did is, if there's a problem with the numpy, so I've uninstalled it and installed again. That is the one thing I did, because it is a package of um, this Mintpy, and then it's a package in the Python. So I've reinstalled again, and then I tried to run, and now I got the program. Now we are going to discuss about the run files. Run one is unpacking the topo reference. Run two is unpacking the secondary SLCs. Run three is average baseline. Run four extract the burst overlap. Run five is overlap geo. Again resample, pairing the misregistered time series, full burst resample, extract the valid region, merge reference, secondary SLC, generate burst, merge burst, filter, coherence, unwrapping. So this one particular program, the stack sentinel pi, has created and also made your files suitable for the covering box or the bounding box, and it also created all the workflows for the interferogram. Now if you can see the folders here, it created the run file, and here you have all these things. All you have to do is just run these data sets. So this is the biggest advantage you have in the uh, this ISE2 and Mintpy. Okay, so each script will have its own um, value. Preparing the reference image, extracting the sentinel mode burst, applying the precise orbit files, co-registration, baseline estimation, interferogram generation, phase filtering, unwrapping, phase unwrapping, and also geocoding. So we'll just have to execute these steps one after the other. Now, thing is, in the beginning stages, even I also tried to run all the scripts at a time, but that is not the case. You have to run each script one by one. Then only you will understand. And the other thing is, we should not edit any kind of script before the execution. These files are automatically generated by ISE2. So, if you really know what it is or what it is going to do, then only you have to edit it. Or you can just leave it like that. And also, the most important thing is when you are running these commands or the scripts, you always watch or observe what this is going on, or what kind of error is showing. So that is very much important. Now next we are going for the next step. We are running the first script, that is unpacking the topo reference, that is run 10. Now the reason why we are going for this run 1 is, in this step it will show you some information of entire workflow. This is like a foundation to the building. Every later step will depend only on this first step. So this must be very properly executed. And why do we execute this one? That is because if something fails, then definitely you should understand why it failed. If you are running all the scripts at a time, then you don't even know what is the problem. So what I'm doing right now, I'm just going to change the directory from change and mount e Mintpy demo, and then go for the run files. Now I entered into the run files directory. From here I came into this run files. Now we'll step by step run them. there is one more thing what you need to do before running these things. That is, you must make them executable. That means they have to run. So we go for ch mod plus plus x run hash slash and star. What this will do? This will make your scripts executable. That means you can run them properly. So I'm running the first stage. What I'm doing is run 01. If there is an error, we'll see. See, it says run and no such file or directory. This is because sometimes we have the um, permission denied, or sometimes we have a wrong directory like that. So what we need to do is we just have to check back again. So we have this error saying that it is like no such file or directory. Then we have to check on few things. One is first you must understand what is your working directory. So you go for pwd and see it is in the run files only. Then you just go for ls minus lh. Okay. And then you'll see all the run packages. And then we'll have to go for ls minus lh run star. So here are the names. Okay, it is run 01 and then it is the name. Now we need to give the proper command. It's not just run underscore 01. It is run 01 unpack topo reference. So we just do the same again. Now go for run 01 and if you press tab, you'll see the name directly. Now you go for this. See, this is what I'm telling. So you have to be very careful in doing the steps. Even after that, you're having some issues. So we'll have to check them. Wait till this is completed, and then we have to go for the next step. See, it is updating the burst and it is cropping and everything is happening. So you just have to wait and let the things to happen. So here, if you see, this error is showing that there is a problem with the dem. That means DEM is not missing. The .xml is missing. Okay. So ISCE2 does not read to a plain geotrip directory. It will expect TIFF .xml kind of things. So what I did is I wanted to check the uh, dem name. So I typed ls minus lh mount e and then in the dem folder I have this .tif and then I searched for the maximum depth type. Then I had only .tif. But ISCE2 is wants for an XML file. Now what I need to do is because XML contains image width, length, data type, pixel spacing, and also the georeferencing. So without it, the TopoPy cannot read the DEM. So now we are preparing the DEM for ISCE2. That means we are converting the GeoTIFF into an ISCE readable DEM by generating the required XML metadata. This is because a GeoTIFF is perfect for QGIS. But when it comes to the ISCE2, it needs XML description file. Okay. So what we are going to do is we'll just change the directory again and go to mount e Mintpy demo and DEM. Here in the directory now. So what we have to run is gidal to ISCE2 XML dot py minus I. Output should be output hh dot diff. See, GDAL isce2.xml is not found. Now, there is one more thing which we need to take care. We are trying to create the XML file and it didn't happen. So, what we need to do is we have to check what is the problem. So, usually this command, when it comes to an issue, we have to check. So, what we can do is we can directly ask the Python to check and verify. Then we can convert the TIFF into the XML. So we are trying to convert that .tiff into a file that is compatible with the ISCE2. So here what we did is we have uh, generally what we do is we can directly open for QGIS or ArcGIS and open the DAM file. So we wanted to use the same DAM for ISCE2. So that is why we have used the GDAL to ISCE XML and it didn't work because the command is not found. So what it did is I went to the conda prefix, the Python library site packages. I have tried to tell the software that this is the output. And then this started the whole processing and I got the number of bands. It's one in float type and length and width. And then once I opened the directory, I had got the TIFF file, VRT and the XML file. Okay, so this is how we are going to do because the utility is not available directly in the terminal. So that is why we are asking Python to execute that one. So that is why I have typed this one. Now, the problem is when you don't activate the Mintpy environment, that will also create a problem. Or sometimes if the DEM path is wrong, or sometimes the utilities which you have installed are not sufficient and you have to install more. See, this particular thing of utility installation or activation will come only with the data processing. That is why even when I am running this data, we still have some errors. So that is why this video is more interesting for you because when you are doing the processing step by step, you will understand the problem. So we'll just go for the next same processing again, and then we'll see what is the result here. So what we did is here we set this run. If you want, you can just copy. And before that, you need to go for the run files again. So I'm changing the directory to cd fnt e mint py demo. And now we have to go for the run files. Run files. So we are in the run files. Now we just go for the first command and type. So when we have executed this sentinel-1 py, we got this first reference, topo reference. So it is unpacking the reference sentinel-1 acquisition, and this processing will establish the radar geometry, the terrain geometry, the burst location, and the coordinate system for the entire stack. Now I again got some error, so I'll have to check again, and then we'll clear this step again. See here, if you see, it's an import error with the libcom. So, what is this? Many compiled scientific libraries, including ISCE2, GDAL, uses this OpenMP for the parallel computation. Now, on the Ubuntu, the runtime library is generally provided in the package lib gomp. If it is missing, the programs that depend on it cannot start, even if they are installed correctly. So ISE2 is installed correctly, but thing is, we didn't have the proper libgov. So what we need to do, we just go for sudo app update, update, and then so you need to remember your password also. So I'd like to told you, it's very important for you to remember your passwords. So I have just installed I did the update. Now I have to install the required file. So the app install minus y will be T. Now we just have to verify if this is installed or not. D. Now we have this installed. Now let us just go back to the folders. CD and home E Mintpy demo and run files. And just let us run this first one. Run 01 track reference. Let us just wait for the step to complete. So it is extracting the orbit from the orbit file.